In this video, we begin by learning how to interpret the results we get from computing confidence intervals. You see, when the confidence interval is at 95%, there is a quantity that we call level of significance of a test that we're going to see in the next lesson, but I want to start preparing you for that. And it is denoted by alpha. If confidence level takes what 95%, then the alpha will take what 5%. If confidence level is 90%, then alpha will be the remaining 10%. Keep this in mind. We'll be right back to this on the next in the next lesson. Another thing that is very important is how to correctly interpret your results for a confidence interval. Take for instance Sarah, who wants to estimate the proportion of people who own a desktop or laptop computer. Now, after collecting sample data from a random survey of individuals, she was able to find a 99% confidence level to go from 0.67 to 0.82. This result, we are required to interpret this 99% confidence interval. The correct way to do that is to say that based on the sample data collected and analyzed, we can be 99% confident that the true but unknown, the true value, or the true but unknown value of the proportion, the population proportion of people who own a laptop computer, of people who own a desktop or laptop computer lies between 0.67 and 0.82. This is the correct way to interpret it. Okay. And another important discussion is the discussion of certainty versus precision when considering confidence intervals. You see, if I were to pick a 90% confidence interval, and if I were to construct a 95% confidence interval, or even a 99% confidence interval, you see, the wider the interval is, the more certain. So certainty increases in this direction. The more certainty that the interval will contain the unknown value of the population parameter. But you see, certainty is a trade-off with precision. If we are precise, then we don't need a very wide confidence interval. We need a narrower one. So precision increases in the opposite direction. In other words, if I told a friend, for instance, that I'll be visiting that friend between 4 p.m. and 10 p.m., compared to another friend who said, I'll be visiting you between 4 p.m. and 5 p.m., well, I might be certain that I have sufficient time to get there between 4 p.m. and 10 p.m., that I'm certain I'll get there, but just that my friend might not like it because it's not a precise time. As compared to the other friend who said I will arrive between 4 p.m. and 5 p.m. So the friend who said I will arrive between 4 p.m. and 5 p.m. is more precise, but might be less certain that they might be able to squeeze their arrival in that time window. As compared to a friend who said, I'll be able to arrive between 4 p.m. and 10 p.m. That is more certain. The only drawback is that it is less certain. So in the choice of our percentage of confidence interval, of confidence level rather, we must be aware of this word trade-offs. It is extremely crucial. All right, let us see another example. In this example, we are told that a random sample of 150 taken from a population yields what? A proportion equal to 0.35. And we are to determine if the sample size is large enough so that the sampling distribution can be approximated by a normal distribution. To do that, we need to check what? The conditions of independence. So we need to check one, the condition of independence, which is usually satisfied because the sample is random. The sample is random. And then we have to also check the success condition, which is n times p. The sample size here is n, and this random sample yielded what? A proportion of 0.35. So we don't have the population proportion. However, we have a sample proportion, which is a good estimate. So 150 multiplied by 0.35. So that will be about what? 52.5, which is greater than 10. And the third step will be the failure count. That will be n times 1 minus p at. That will be 150 multiplied by 1 minus 0.35. This is equal to, make sure we write that well, that is 97.5, which is also greater than 10. With this, we can use what? The sampling, we can use the normal distribution as a reasonable estimate. And based on this, we are to construct a 90% confidence interval for the population proportion. Here we'll need the sample size, the number of observations, 150, and we'll also need P, we'll need X, the number of successes. Our X in this case would be determined from the realization that X over N is equal to P at. Our P at was given as what? 0.35. And our N was 150. So to solve for X, this means that X is equal to 0.35 cross multiplying multiplied by 150. What would that give us? So that would be, in my calculator, I have 0.35 multiplied by 150. That gives us 52.5, which we had earlier. That we can approximate above because there is no human being that is 0.5. So we take it to 53. So we can take this back to StatCrunch. So going back to StatCrunch, what do we have? So I'm going to zoom in back in here. I go to statistics, proportion, one sample with summary. For my number of successes, I want 53 out of 150 approximately. And I'm going to look at the confidence interval, and I want 0.90 for a 90% confidence interval. And I like to store the result and the critical value if I want and compute. So here I have the values. The lower limit is 0.29 or 289. So my confidence interval here is 0.289 to 0.418. That is the 90% confidence interval. And we are required next to interpret the confidence interval. So we can say that based on the sample data analyzed, we can be 90% confident that the true but unknown population proportion lies between 0.289 and 0.418. The next question says we should produce the margin of error. Margin of error, as we learned in our earlier notes, let's go back. Margin of error is always upper bound minus lower bound divided by 2. So let's bring that forward. So upper bound minus lower bound divided by 2. And that will be equal to 0.418, the upper bound, minus the lower bound divided by 2. So you have 0.418 minus 0.289 and then divided by 2. So that will give 0.0645. The next part of the question said if we wanted to be 98% confident instead of 90% confident, would our confidence interval need to be wider or narrower? What do you think? I would say that the correct one would be wider, because if this is 90%, 98% will be even what? Wider. Okay? Then the next part of the question said, without increasing the sample size, suppose we wanted to reduce the margin of error, this margin of error, would our level of confidence need to be higher or lower? Remember, your margin of error determines the stretch above and below the point estimate in the middle. So, if we want to reduce our margin of error, that means we want to collapse the hand, the outstretched hand. We want to reduce how far stretched out those hands are. If we are reducing that, that means we'll need to definitely lower our what? Confidence. So here we need to lower the confidence level. Because by lowering the confidence level, I'll be what? Shrinking the confidence interval. I'll make it narrower. And that would also mean that the margin of error would, as a result, become lower. Question G, if a larger sample size was taken, which means you're getting more information, would the interval's margin of error likely have been larger or smaller? With more information coming from the sample size, we anticipate that the margin of error should become smaller. So the correct answer here would be smaller.